Okay, here I have this website. So here, if you go to chapter-wise simulations videos, um, you can go to waves chapter, and when you click on the waves chapter, it will take you to some of the simulation links I have given here. So you can actually make use of these simulations for your learning and teaching purposes. Um, so when you click on this, um, it will give you this simulation. Let's see. I would like to talk a little bit about phase difference. So very often students, when they come to waves chapter, they find it a little bit difficult with this basic principles. So I thought, maybe I can explain it with this simulation. So if you see this red one and this red one, when this is coming down, this is also coming down. When this is going up, this is also going up. So we say this A and E are in phase. And if you see this yellow balls, B and D, you see the B is going up, D is coming down. And now B is coming down, D is going up. So it's like, 180 degrees, 180 degrees apart. So that means we say it is out of phase. The same thing is applicable for other particles also. Whenever it is 180 degrees apart, look at C and E. So they are 180 degrees apart and we say it is out of phase. Same thing for A and C. So I hope you are able to follow what is in phase and what is out of phase. Um, Next thing we can talk about is um, in a oscillating particle, right? Like in oscillations, what happens is we talk about oscillation of one single particle. But in a wave, as you can see, there are many particles vibrating or oscillating, and they are not oscillating like this, right? They are not oscillating together. There is a phase difference between each and every particle. Okay, and this is a very important concept for us to understand because you see this wave equation y is equal to a sine omega t minus kx. So you have something called omega t term and then you have something called kx term. So it becomes important for us to understand each term properly. And if you have seen the oscillation of a particle, you would have got only a sine omega t. There will not be this kx term. If you wonder why there is this kx term, this is nothing but your location. X refers to the location and omega refers to your angular velocity. So in the handbooks, I have given you some material to understand, what is wave number. So let's quickly go through this. So frequency is 1 by t. Angular frequency, which is omega, is 2 pi by t. Wave number is in one, wave number is equal to 1 by lambda. So it means in one lambda, how much waves you have or how many oscillations you have. Here in one time period, how many waves or how many oscillations are there. Right? Or maybe I should not say oscillations, waves, right? One full wave. An angular wave number will be 2 pi by lambda because it's radians per second. Here you have 2 pi by t, which is radians per second. Here it is radians per meter. Okay. So I hope you are able to understand or appreciate that in an oscillating particle there is only one particle and it's changing with respect to time, which means you will have only omega t. Now in a wave you have many particles oscillating. So that's why you have the second term called kx, right? So That's the importance of this. So the main purpose of the simulation is to show you, what happens when you change the omega. So I have some slider here. So if I increase the omega, see what happens. So as you can imagine, as omega increases, the speed of the wave, the speed of oscillation has increased. And if I increase the k, as I told you, k is in a given, um, so it's like 1 by lambda, right? So what happens is when you increase the k, the lambda will decrease because k is equal to 1 by lambda. Okay. And amplitude, I think this small a here I given capital A, but here, I use small a, doesn't matter. So if I increase the amplitude, you can see the maximum displacement increases. Okay, so amplitude is an easy thing. I'm sure all of you will be able to follow, but many of you will have some trouble with omega t and kx. So I hope this helps you to understand this omega and k terms. Okay, and one more thing I can share here is this capital T is in seconds. If this is in seconds, this should also be in seconds. So second cancels, I'll be getting in radians. Similarly, lambda is in meters, x is location, which means it is also in meters. So these two terms will cancel each other. I mean, the units will cancel, and you will be getting in radians. So that means whatever you have in the brackets, it should be radians. And as you must be knowing that radians is dimensionless. Okay, so that's why these dimensions should cancel each other. Okay, thank you.